Shipping is a vital part of our global economy. It allows for the transport of goods across vast oceans, connecting nations and fueling trade. However, this essential industry comes with an environmental cost. Ships, particularly those powered by diesel engines, are a significant source of air pollution, including harmful nitrogen oxides or NOx emissions. NOx emissions have severe consequences for both human health and the environment. They contribute to respiratory problems, acid rain, and the formation of smog. Recognizing the urgent need to address this issue, the International Maritime Organization, or IMO, has introduced increasingly stringent regulations to curb NOx emissions from ships. The shipping industry is facing growing pressure to minimize its environmental footprint. Sustainable practices are not just an ethical imperative, but also a business necessity. As awareness of the impact of shipping emissions grows, so does the demand for cleaner technologies and responsible practices. Reducing NOx emissions is a complex challenge that requires a multifaceted approach. This includes technological advancements, operational improvements, and the implementation of international regulations. By working together, stakeholders in the shipping industry can ensure a cleaner, healthier future for our planet and its people. Nitrogen oxides, or NOx, are a group of gases that form when fuel is burned at high temperatures, such as in ship engines. These gases, primarily nitrogen dioxide and nitric oxide, are invisible but have a significant impact on both human health and the environment. One of the most concerning effects of NOx emissions is their contribution to respiratory problems. When inhaled, these gases can irritate the lungs, exacerbate asthma, and increase the risk of respiratory infections. Children, the elderly, and people with existing respiratory conditions are particularly vulnerable to these effects. Beyond human health, NOx emissions also have detrimental environmental consequences. They are a major contributor to acid rain, which acidifies lakes and streams, harming aquatic life. Additionally, NOx gases react with other pollutants in the atmosphere to form ground-level ozone, a key component of smog. Smog reduces air quality, limits visibility, and can damage crops and forests. Addressing NOx emissions is crucial for protecting human health and preserving the environment. By implementing stricter regulations and adopting cleaner technologies, the shipping industry can significantly reduce its contribution to air pollution and mitigate the harmful effects of these emissions. The health and environmental impacts of NOx emissions are far-reaching and demand immediate action. Reducing these emissions is not just an environmental concern, but also a public health priority. By transitioning to cleaner shipping practices, we can create a healthier and more sustainable future for all. The International Maritime Organization, or IMO, introduced the MARPOL Annex to 6 regulations to control air pollution from ships. These regulations set limits on sulfur oxide and nitrogen oxide emissions from ship exhausts. The NOx Tier 3 standard specifically aims to significantly reduce NOx emissions from newly built ships operating in designated emission control areas, or ECAs. NOx Tier 3 standards require a substantial 80% reduction in NOx emissions compared to the previous Tier 1 standards. This regulation applies to ships constructed on or after January 1, 2016 that operate in designated NOx emission control areas, or NECAs. These areas, primarily located in North America and the US Caribbean Sea, are particularly sensitive to the effects of NOx pollution. Meeting the MARPOL NOx Tier 3 standards requires shipbuilders and operators to adopt advanced technologies and practices. This includes using alternative fuels, implementing exhaust gas cleaning systems, and incorporating engine technologies that inherently reduce NOx emissions. Compliance with MARPOL NOx Tier 3 standards is not just a regulatory requirement, but also a demonstration of the shipping industry's commitment to environmental responsibility. By adhering to these standards, the industry can significantly reduce its environmental footprint and contribute to cleaner air and healthier communities. Direct water injection, or DWI, has emerged as a promising technology for reducing NOx emissions from marine diesel engines. This innovative approach involves spraying a fine mist of water directly into the engine's combustion chamber during operation. The water, as it evaporates, absorbs heat, effectively lowering the peak combustion temperature. By reducing the peak combustion temperature, DWI significantly inhibits the formation of NOx. These harmful gases are primarily produced at high temperatures. By effectively cooling the combustion process, DWI directly targets and minimizes the primary source of NOx formation. In addition to lowering peak temperatures, the introduction of water vapor into the combustion chamber also displaces oxygen. This reduced oxygen concentration further limits the conditions necessary for NOx formation, enhancing the effectiveness of DWI in reducing emissions. Furthermore, the presence of water in the combustion chamber slows down the overall combustion temperature rise rate. This controlled combustion process contributes to lower NOx emissions by providing less opportunity for these harmful gases to form. DWI offers a practical and effective method for the shipping industry to meet increasingly stringent NOx emission regulations. By directly addressing the conditions that lead to NOx formation, DWI provides a targeted approach to reducing these harmful emissions.